Hello, everybody. It's a great pleasure to have one of my senior PhD students, Sajjad Rahnama, to give us a ResilientDB hands-on tutorial. ResilientDB, as I mentioned previously, is a blockchain fabric that has been developed in-house at UC Davis for the past 3 years. And overall, about 10 students have been working on it. Core graduate student and undergraduate student have been working on this platform for the last 3 years. And of course, there's about over 100 students that have used the platform for courses such as 265. And this quarter, hopefully some of our 189 students will also be benefiting from this platform. So without further ado, so Sajjad, please take it away and give us a solid walkthrough of what is ResilientDB all about. Thank you.
So hi everyone, can you see my screen? Hello, I'm Sajjad, a PhD student at UC Davis. As you know, I'm working with Professor Sadouri. Today I'll be explaining ResilientDB, how it's working and how to start coding with ResilientDB. This tutorial, I think, would have 3 parts. The first part is the introduction. The second part would be how to run ResilientDB with Docker. The third part would be how to run ResilientDB on Google Cloud. And add minor adjustment to the code and explaining what are the different parts of the code. As you can see, ResilientDB is the website. You can go to this website. We have open source GitHub version of it. You can go here and just clone the code. Can you clearly see my terminal? Is it visible? Okay. I have ResilientDB here. We have the directory structure, as you can see here, the same thing here. I've cloned the vanilla version of it. The first thing I want to say about ResilientDB.
So Sajjad,
yes.
Sorry, so there's a comment saying if you can make the font a little bit bigger, please.
Can you see now? Not.
Maybe just slightly bigger.
I think that would be good.
Perfect.
Okay. The code has been written in C++, mainly C++. We have 4 dependency that we are using: Crypto++, Boost, Gemalloc, and NanoMessage. NanoMessage is for socket programming. We completely delegated the TCP transportation level to the NanoMessage library. It has the library for pairing the nodes in network, and just give them a byte array to send and receive. The rest is the responsibility of transport layer of ResilientDB to create messages, to compress messages to the byte arrays, and all those stuff. You do not need to make or install all these dependencies. They are all have been made, and they are all zipped or tarred. You can just untar them. I'll be explaining how to just untar them in few minutes. So the first thing is that ResilientDB is a distributed code. You need to have different machines to use it. Whether you need to have different virtual machines, different actual machines, or the easiest way to run it on the single machine is to use Docker. Because usually people do not have access to the cloud, to different machines. We have provided a Docker version of it. So there's a script here which you give the number of nodes and clients you want to run. It will create Docker Compose file. It will create the containers for you, and it will run the ResilientDB. After that, I will be explaining how to run on different Docker containers individually. The first thing I want to talk about is the config file. We have a config.h file that is quite big. The most of parameters here you do not need to worry about. I am just going to explain very few of them. The first thing is node count. How many nodes do you want to be in the system? The next thing would be the client node. How many clients do you want to be in the system? As I will be explaining later, the ResilientDB is a completely pipeline fabric. It means that in order to process messages and sending all those things to different nodes, we have a very complex pipeline which has a different thread for input threads, for output threads, for doing the actual consensus, for processing the batching of client requests and all those things. The number of threads that you can you see my cursor? Yeah. So here is the number of threads you specify for your pipeline. These are a little bit more complex. You need to, you do not need to touch them once you want to start working with them. And the important one left is how many minutes do you want system to be run? How much warm-up time do you want system to have? And what protocol do you want to use? Right now, the only protocol that has been open source is PBFT. I'll be explaining what is PBFT, Practical Byzantine Fault Tolerance, and how it's workflow. And the default version and the default setting is PBFT. The ZZ1 hot stuff, all those others are not published yet, but we are going to publish them soon. So the only choice that you right now have is PBFT, and this parameter is for this, and the rest is all other parameters you do not need to worry about. So first thing to run, we have a ResilientDB Docker script there. In order to run ResilientDB Docker, you need to have a Docker engine on your machine. So if I do Docker PS, so my Docker is running and working, my Docker engine, because Docker PS is Docker client. So when I do Docker PS, it means that Docker engine is working and it is saying that there is no container here. So we have a ResilientDB Docker command. So it's saying that in order to use ResilientDB Docker, you need to specify the number of clients and the number of replicas. I will be doing 7 replicas, for example, 6 replicas, and for example, 4 clients. So what's happening in this script? This script is just a shell script. It will get your parameters from here. It will create the config file.h that was there. It will create that file with your specified parameters. Then it will create a Docker Compose file, creating 10 container based on the number of clients and node you have specified. It will create S1 through S6 and C1 through C4. It will create 10 Docker container, and then it will run those container, fetch those IPs, because in order to nano message to communicate and send message to the other node, they need to have a specific IP address for them. So it will extract all the IP addresses that Docker will give you by itself. It will sort them. In order to run ResilientDB, you need a ifconfig file.txt that this script will be creating for you. Ifconfig.txt file is the file that you need to put your IP addresses in it. Once it extracts the IP addresses from the Docker engine, it will create this file. And after that, it will try to install dependencies. Installing dependencies is just untearing or unzipping all the files in the deps folder. It's very straightforward. You do not need to worry about it. And after that, it will start making ResilientDB. It will do the make clean command and make ResilientDB. As you can see, the ResilientDB is being made. And after that, it needs to distribute the binary file that has been made to different different Docker containers. But in order to make that easy, we have shared a folder between those Docker containers and put the two binary files, RunDB and RunCL, in that directory. So every container can have access to this. And after that, it will run RunDB on the, yes, go ahead. Anybody has a question? You can just unmute yourself and ask your question if you want. No question. So, okay. So as you remember in config file.h, we have 2 minutes of runtime and 1 minute of warm-up. Right now, the first 1 minute would be warm-up, and the second 2 minutes would be actual consensus being done and measuring the throughput and latency. While it's running, I'm going to talk a little about PBFT and how PBFT works. So I explained how to run the ResilientDB Docker command and what is Docker. I will be explaining the pipeline later on, but first we need to go to the PBFT. PBFT is the first practical Byzantine fault-tolerant protocol. It is a permissioned blockchain consensus protocol. It is communication-based, and it has 2 rounds of squared communication and 1 round of linear communication. As you can see in this workflow, I will be explaining that. If you have a 3 replicas, if we have 4 nodes in PBFT, we usually assign one of them as primary. In ResilientDB, the first one is always primary as a default, but in case of faulty primary, it will be changed. But right now, the primary is always the first node. We have clients. Clients will create requests. As you can see, T, they will send that T request to the primary. Primary will create pre-prepare messages and broadcast it to the all nodes in the network. And after that, everybody will create prepare messages and send to everybody. So we have a everybody to everybody communication in the prepare phase. And after everybody gets to a sufficient amount of prepare message, they will start sending commit messages to everybody. And after everybody receive sufficient amount of commit messages, they will execute the transaction and send the reply back to the client. In order to understand this workflow, you need to read the PBFT paper. I don't want to go over it and explain how PBFT exactly works, but the least thing you need to know is that the PBFT has a 3 round. The first prepare round is a linear, 2 round of square communication, and the client response. The thing that is being run right now on the ResilientDB is just this. Clients are creating requests, sending those requests to the primary creating pre-prepare messages, sending to everybody. Everybody, after receiving pre-prepare message, creating prepare messages, send to everybody. And after that, sending commit message to everybody. And after receiving sufficient amount of commit messages, they will execute the transaction, add it to the chain, and send the reply back to the client. Any questions?
Could the primary also be Byzantine by any chance or no?
Yes, yes, yes. Primary can be Byzantine. We have a view change protocol to replace the primary, but all those things is next level. We don't want to talk about that because they would it would make it a little bit complex. But yeah, in ResilientDB, we have a view change protocol implemented that can replace primary in case that primary is Byzantine or faulty or crashed or anything.
Wait, so what's the difference between the primary and the replica again? Can you explain that?
Primary is a leader. Primary is a person who needs to sequence the transaction and lead the consensus protocol in PBFT. So every client request goes through primary. Primary assign a sequence number to it and then send everybody. So people can have a linear can have a sequence of transaction, ordered set of transaction. The primary is kind of orderer. If you know the Paxos, the primary is kind of leader there.
Why do you need a separation between the client and the primary though?
So let me just interject here, sorry. So I don't want to carry away. So the notion of the primary here is the same as the coordinator we talked about in 2PC. This paper is going to be covered in full later this quarter. So, and it has a lot of interesting questions, but I think if we start talking about the protocol, then we're not going to have time to actually looking at.
Sounds good.
Yeah, but this is going to be covered. Again, this is number one. This is the most important protocol, I think, that you all going to be learning in this course. And Hyperledger uses it. There's other platform who uses it. So we will definitely spend a good amount of time on this protocol later.
So any other questions?
Sorry, I'm from ECS 189F with little knowledge about PBFT. Can you explain what is Byzantine replica?
A Byzantine replica is a malicious replica that can act as a malicious node, and it can prevent sending message. It can sending different message to different people. It's kind of a faulty node.
Okay, great. Thank you.
It would have mandatory behavior, random behavior. It can act as one. Yes. Any other questions here? So the walkthrough in the code would be going through the client and reach the process execute transactions. So we're going to see how the client will create those client requests in the system, how they will send it to the primary, how primary create those prepare messages, and the workflow. So if you want to implement your own protocols, you need to just change this workflow. For example, if your protocol that you want to implement says that the client needs to send the client request to everybody, you go there, you find where the client is sending the request to the primary, and you change that part and make it to send to everybody. And if, for example, in your protocol, the prepare stage is linear, you do not need to send to everybody, you just go there and change the destination and make a minor adjustment to make your own protocol. So if I go here, okay. So the ResilientDB has been run successfully. And after that, we have a script to gather the results from the Docker machines and give you a summary here. As you can see, we have 9 nodes, and the first thing is throughput. As you can see, we have the throughput of 7K, almost 7K in 6 nodes, and the throughput of 1700 transaction per second in our 4 clients. And here are the latency numbers. They are all in the different files in different Docker containers, but the script has gathered them and showing you the summary. The rest is the idleness of threads of pipeline. I will be explaining how pipeline works, but the amount of idleness that the threads have means how much you are exploiting your computation power in all nodes. For example, the first one is worker thread, the last one is checkpointing thread, and the execution thread, and all different ones. Right now, you do not need to worry about these things, just the throughput and latency. And
wait, so is the 6 through 9 referring to the client nodes, or are they referring to?
Yeah, 6 through 9 referring to the clients. The first 6 are the replicas. The last 4 are the clients. So the sum of throughput of clients would be the throughput of nodes here. Is that clear?
Yep.
Okay. So here, this way of running ResilientDB is just for demo. You cannot do anything by running the ResilientDB Docker script. So if you run it in this way, you cannot change anything, you cannot monitor anything. You will just having system run and receiving the results finally. The one way of doing it with Docker is to run yourself on individual machine. So I have different terminals here to run it on different node each. one by one. This approach is just for development. If you want to develop on ResilientDB, you might need to run it on different node and see the results and everything online. I don't think you can see very good, but I try to make them.
And just a kind of a note to see just even the impracticality of it. So some of the latest deployment that Sajjad has done, which are, I think, by far the most exciting, and I think no one in the in academic or even industry have reached the scale that we're talking about here. Over 500 machines, replicas globally across all continents, many different countries, and still getting transactions of 1 million per second. So very interesting. I think there are many interesting deployment that we can do, and just that all goes to the efficiency of ResilientDB. Its runtime, its pipeline, the consensus protocol that we've been developing over the years. So I think there's a lot of exciting stuff for anybody who really wants to join this journey.
So as you can see, I have, I think, 6 terminals on the left side, and am I right? How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I have 10 terminals here. I will be here. All of these terminals are the machines that have been running Docker. In order to go to those containers, you need to do command docker exec. The command docker exec will execute a command inside your Docker container. As you can see, I'm running bash and I'm giving it an IT flag. That means I need an interactive bash inside that container. So I will be running S1 here, I'll be running S2 here, S3, S4, S5, S6, it would be C1, C2, C3, and C4. I have all the machines there. So if you can see, after this part is being is done, the 2 binary file will be present here. As you can see, RunDB and RunCL. The RunDB is the binary file that you need to run on your replicas, and the RunCL is the binary that you need to run on your clients. And in order to specify which machines I am running, you need to pass a parameter to it. For example, this machine is S1. I would be running a replica, so it would be RunDB, as you can see. And in order to give it that you are the first node, there would be a parameter of NID. I will be giving NID 0 to it. So it will, as you can see, here is how ResilientDB is exactly being run. Here is the config file parameters that being set that you have set in the config file. Here is the IP address of different node that it has and creating the sockets for them. And after that, binding the sockets to different port of different machines based on how many input and output thread you have. And after that, it will initializing the message queues, transaction pools, transaction table pools, and all those stuff. And after that, it will be creating the CMAC, symmetric signing keys for the different pair of nodes. For example, if I am a node number 1, I need to have a key with, if I want to do symmetric key encryption, I need to have key with everyone in the system. So I will be creating the CMAC key with all of these nodes and transferring definitely those keys with all those nodes. And after that, it will be sending the init done message. The init done message is supposed to make the initialization of the protocol. They will send init done message to everybody. Once I receive init done message from everybody, it means that everybody is online and everybody can start running the system. And as you can see, it is waiting to receiving the init done messages. As you can see, it has sent the init done message to everybody, but it hasn't received anything yet. So it will be waiting to receive init done message, and after everybody received init done message from everybody, it will start running the flow of protocol. But again, you do not need to worry about this part. This part all has been done. You need to just change the workflow if you want to implement something in ResilientDB in an easy way. So I will be running RunDB 0 on this machine, RunDB 1 on this machine, 2 on this machine, 3 on this machine. So here should be run CL. So as you can see, they will receive the init done message here. It has received init done message from everybody. After that, they will start running the actual consensus. As you can see, after they receive init done, the threads, the worker threads, the input threads, the output thread will be start being run. And yes, we have a stats layer that gathers everything is happening in the fabric and shows you every 10 seconds. And as you can see, every 10 seconds, we have an update here with all parameters. For first 60 seconds, it is warm up. There will be no measurement and the results would not change. Everything is 0. As you can see, the throughput is 0, the transaction count 0, everything is 0 because it's warm up. Warm up is supposed to fill all those queues, is supposed to fill the pipelines, everything to make sure everything is in the same state to start measuring everything. And as you can see, yes, for the first 60 seconds, nothing will be happening, but after that, it will start. As you can see here, yes, here is 60 and the throughput starts getting values. This is the node number 0, so it is a primary one. As you can see, the throughput is rising. The throughput right now in the ResilientDB is accumulative, so you cannot, it will be increasing. I will be changing it to the non-accumulative and non-accumulative version later on, but right now you will be seeing rising in throughput. As you can see, the throughput is being increased, the transaction count is here, how many milliseconds, work queue wait time, and all these parameters. Right now, you do not need to worry about it. So after, I think, 2 minutes, it will be done. And the script that was running ResilientDB Docker was supposed to gather all these files. Every node has its own results. That script was gathering these things and just printing you out the throughput, the latency in the clients, and the memory usage. And of course, idle time of worker threads. So as you can see, it's just showing you the throughput and latency. Now I'm going to walk through the code and show how make an adjustment and how see the results of what's happening in the running time. So I will be stopping them and I will go to the code. Is the size okay? I cannot see the chat. If anybody cannot see the, so you can see. So this was the config file I was talking about. You can, so right now, from now on, if you want to change something, you do not need to run ResilientDB Docker command because that was just a demo. For the first time, do run that because it will be untearing and unzipping the dependencies for you, and it will make easier for you to do so. From now on, you won't be running those. If that command, if you want to develop something on ResilientDB, so you can directly just change these numbers and just compile the code and run in those different terminals that you previously had.
So just kind of a note, if you have any questions, sort of ask. If you hear a term that you're not familiar with, and that's, I think, expected, so just ask, and especially now that we are kind of beginning to go into more detail, I think now it's a good time. So, and if you need to go over the hour mark, that's fine. We can continue the meeting. But again, it's important to ask any questions, any question that you have, so that later you can actually take this tutorial and help you to get started.
Anybody, any questions? Nothing. So I think I can continue. If at any point of time you had a question, just stop me and ask your question. So we have the directorial structure here. Right now, in order to make it simple for you, you do not need to worry about these benchmark, blockchain, dashboard, DB, depths, scripts, statistics, and a smart contract folder. The only folders you need to take a look at it is a system and client folder. For the rest is not just right now your concern. The most important part of the consensus is happening in the system folder and the client folder. Where is the client folder? Here. So as you remember, we have a RunDB and RunCL. Each of those files has their own main file. You do not need to change those main file, but I just gonna explain. There is a main file for the client that is doing all the initialization, all the things that you were seeing in the log file of each the client node, creating the workloads and initializing the message queues, initializing the network, creating keys, and all of those stuff is happening. After all the initializing being happened, the client thread would be run. The client thread is in system folder. I'm starting from client because the workflow of PBFT was starting from the client. Client was the one that was initiating the workflow, creating client requests, and send it to the primary. And you can see the client thread is here. There are a couple of functions you need to look at. The most important one is the run function. The run function is a while true loop that is just creating client request, sending it to the primary, waiting it for a response. Creating a client request, sending it to the primary, waiting for the response from the node, and creating these things again and again. So as you can see, we have a while true called while simulation is done. Just do a heartbeat, progress stats, find. I don't want to go very in detail. You can find and understand it yourself. I'm just trying to explain it a little bit abstract, not go deep into the code. In this part, client will find who is the primary right now. In the PBFT, primary is tied to the view. Each view has its own primary. And when we are saying next node ID is get view, it means who is the primary right now. It will find the primary. Who is the primary? It will create batch request. Batch request in ResilientDB is the same as pre-prepare request. PBFT allows you to batch the client's request in order to make consensus fast. So the client will batch the request. For example, it will gather 100 requests together and send them as one request to the primary. So as you can see here is looping over the batch size and creating a client query and adding them to the batch request. And as you can see, once it reaches to the number of batch size, it will sign the message with the key of primary, and it will create a vector called destination, puts the destination number in it, and put the message in the message queue. The message queue is responsible to provide these messages to the output thread, and output thread will send these messages to the destination node based on the vector called test that we are providing to the message queue. And after that, it will do the same again and again. This is the while true loop that is happening while simulation or the code is being run. So here is the client. Once client sends everything to the primary, now we are going to see what's happening in each replica. The whole process of replica is a while true that is waiting for the message from different node and act on those messages. For example, every node is waiting to receive a message. Once it receives the message, it will process that message. So we have a different message types that I will be explaining where you can see all those message types, but they will receive a message, and based on what type of is that message, they will do something. This process is happening in two functions in worker thread file. Worker thread is where each node is doing something. Just give me a minute. Why we have a lot of functions here?
And kind of, so again, intuition is that when we think of either 2PC that we talked about or the PBFT protocol that we talked about, there are different phases. So that means whether you're replica or the primary, you kind of an event-based mechanism. So you kind of wait for messages. Once you get your client message or once you get your prepare message, then you move on that flow. And you can get the messages out of order. So it handles all the out of order processing of those messages. But again, at every phase, you constantly wait a message, you get in a message, you act upon it. You either start a message could mean a new consensus, or a message could be from one of the previous page, from the previous consensus that is still ongoing. So it advances one of those phases that we talked about. So we started with a pre-prepare, and then we go to prepare, and then we go to commit, and then informing the client. So at any point in time, you could be in one of those phases for many parallel consensus or that is kind of happening at the same time. Because again, we're not processing one client batch at a time. We start one client batch, and while we're finishing the processing of that, we start another one. So there's like in-flight or in-transitioning batches that are happening in place. Of course, when the time of the execution comes, even if you process these consensus out of order, the execution still ensures you get a serial order execution at the end. So the serialization does happen. And every batch that comes to every batch of client messages that comes to the primary tags it, adds a sequence number, it adds essentially a timestamp to it. And by adding that timestamp, by adding that sequence number, it situates it or it orders it with respect to the previous and future batch of transaction. And now using that sequence number and that timestamp, each replica, as they're getting these messages out of order, they can connect the dots together and they figure out, okay, this relates to that part of that round of consensus. And when you get that message, it progresses that particular round. So again, if that's helpful.
Anybody, any questions up to here? So guys, I know this is a huge code base and understanding it would be difficult, but if you want to work on ResilientDB, the best way is to trace what's happening with the workflow of PBFT. If you want to understand it, go from client, find what's happening after client sends the message, what happens to that message, what will be happening to the response of that message, and tracing the workflow would make you easier. Just don't start, and if you want to work on ResilientDB, don't start reading each function, trying to understand what that function is doing.
And again,
So,
it's an incremental process. So it's not a process that you can just look at it overnight. Okay, I understand the entire platform. It's something step by step, adding print statement, adding sort of traces to you start gradually learning. And again, since we're working in groups, and you can not only collaborate with members within your group or across the groups on Slacks and all of that, that will give you the additional help. And also, I want to also add this: the code is complex, but if you compare it to Hyperledger, for example, or more mature sort of product, which have hundreds of people have been working on it, or maybe thousands of developers have been working on it, still the code is much, much simpler in terms of its size and its complexity, because it doesn't have all the bells and whistles. For example, IBM DB2 code base, I mean, numbers goes around anywhere from 10 million lines of code to even larger. And again, millions lines of code, again, you find it in sort of well-established databases, in well-established operating system. So it's important to be able to deal with a large code base and understand it. And this is in comparison, I think, is still considered, I would say, as a research prototype. So it's much simpler, it's more modular, it's much more simpler to digest. And of course, we have a lot of tutorials around the two in addition to what we're offering today. So I think that might be a good stepping stone in order to get into the building engines and sophisticated software open source. I think this is a good step. This is a good entry. There is a learning curve, but this is something that you need to master, and this is something that you need to learn of how to digest and parse and read code, because that's going to be an essential skill set, whether you're undergraduate or a graduate and you're planning to go work in a research lab or planning to work in a software company. These are important skills to develop. And honestly, the only really way of doing it is to just take an open source project and take the challenge, and you kind of experiment all aspects of it, read of it, print statements. So you have to develop what's best works for you in order to read code and understand code.
So let's continue. As you remember, when we want to understand the client, we went to the run function. The run function is the main loop of each node that is being run. The client was running the client thread run function. Here, all replicas are running a worker thread run function. So as you can see, again, this run function is also a while true on this on the whole code. What it's just doing loop on the message queue and try to dequeue message from the message queue, from the work queue, sorry, from the work queue. Once input thread receive messages from the network, they will put all those messages in work queue. So all nodes will be waiting for a work queue to have messages, and if it can get something from work queue, it will do some initialization and then process message. So the process is like this. The node will wait for work queue to receive a message. Once it receives the message, it will process that message. And as you can see, the process function is just a switch case on different message type. If message type is a key exchange, we call process key exchange. If it's a client batch, we will call the process client batch function. And as you can see, based on the message type, it will call the different functions to process different messages.
Again, so again, that's sorry, Sajjad. So again, that's the part that it grabs which phases of consensus for which round is doing it. So that make the progression that I was referring to. So that's the essential piece that Sajjad is covering, sort of connecting the dots.
If in your protocol you want to create new message, you want to add something new, you can just create your own message that I will be explaining in the transport folder. And in the worker thread, you need to just add a case here based on your message type and write your own process message type. So right now,
so one more thing. So Sajjad, one more thing. So again, so why is this important? Is that if you're building a PBFT protocol and you have an optimized version that you need to drop one message type, well, we know where to go. Or you have a new protocol that has slightly different phases from PBFT. So again, we can look at PBFT, okay, so this is the phases, and I need to perhaps drop this particular phase, drop this particular message type, and introduce a new message type that is perhaps a variation of the one that PBFT has. Maybe it doesn't have the quadratic communication that we talked about, maybe it has a linear communication. But again, if you follow the process, the workflow of the PBFT, which really captures the entire consensus and all the optimization and the runtime and the pipeline and everything else that ResilientDB offers, it allows us not only to optimize, for example, PBFT itself, but use the PBFT as a basis for implementing new protocol. And that's what we kind of have been doing. So the dozen protocol that we have, all of them is based on this sort of what Sajjad is referring to. So they're all going to be variation, adaptation, and sort of plug and play of different components. But that's the flow, that's the basis. Those are the necessary sort of steps.
So, okay, I'm going to go to the process client batch. The first step is processing client batch. If you remember this part, when the client sends the message to the primary is the only one who is receiving the client batch. The client batch is the same as client request. At this part, the process client batch will be called in the primary node. And as you can see here, we are going to here, and we will be just printing out that the primary has received a client query batch. I will be compiling the code and running and see who is receiving what from which message. I'm just confirming whether just the primary is receiving the client batch or everybody is receiving client batch, just to see what's happening here. So I have changed this. As you can see, I will be make clean. So once it gets finished, we can now run that in these machines. As you can see, after I compiled the code, I didn't move RunDB and RunCL anywhere, because all of the containers S1 through C4 are sharing this directory. All of them, their working directory is the same directory, so the RunDB and RunCL will be available for everyone. Oh, sorry. I think I have changed the config file. We had 6 nodes and how many clients? 3 clients. I mean, no, 4 clients. Sorry. Sorry, my bad, guys. Then I changed the print statement on that file. I also changed the number of nodes in the number of clients in the config file. As you can see, the only one is receiving client query batch is the first node, which means the primary. And as you can see, we have two batching threads. I will be explaining later who is processing these client batch, thread 1 and thread 2. We have two threads just working on the client request because they are huge and the processing of them, creating transaction managers takes time. And as you can see, they are receiving from different clients, client number 9, number 7, number 8, number 6, and different clients. And nobody else is receiving anything from the clients. So the workflow right now is the first step. The next step, after I will be showing you how this client query, the processing will be working. The first step is to validating message, checking that it's been signed by the client who is claiming that sending message, and validating the signature. And if it's right, it will call create and send batch request. Batch request, as I explained before, is the same as prepare messages. Because we are doing batching in PBFT, the name of the message, the first client request and client pre-prepare message are different. They are client batch and batch request. Client batch is the client request. Batch request is pre-prepare message in the PBFT. Batch request is this part, pre-prepare. The primary will create and send batch requests at this part in processing client request. So when it's trying to creating batch requests and sending to everyone, as you can see, it will loop go over the batch side. It will create transaction manager for each request that client has sent, because finally this node as a primary itself needs to have the chain, it needs to have the transaction manager for all the requests, and finally execute those after the consensus is done. So it will initializing the transaction managers here. As you can see, initializing transaction managers based on the client query set, creating the digest. As you can see, it is the creating a string from all the messages inside the batch, and finally creating a hash from that string and call it as digest of message. If you read the PBFT paper, primary needs to add a digest to each client request and include it in the pre-prepare message. And after that, it will after it creates that batch request, brake means batch request. It will sign that batch request, and this function would create a vector containing all nodes and just passing it to the message queue. So it will create transaction managers, create a vector of destination, and give it to the message queue. So message queue will do this part. Message queue will give that message to output thread, and output thread will send those messages to everybody here. After everybody receive pre-prepare message, they should send prepare message to everybody. So what's happening in the other node? After nodes receive, let me go to the process function. Here, once a node receives batch request, it will run process batch function. The process batch function, I will again uncomment these two lines. And I can run the code. And as you can see, all of nodes are receiving batch requests from the primary. As you can see here, they all have a transaction ID here. Last 2 digit is the batch size, and the first digits are the transaction ID. For example, here is 0, 2, 3, 4, 1, 6, 7, and they are receiving out of order because the consensus can happen out of order. And after they will receive the batch request, they will do this process again and again. They will, after they receive batch requests, they will create prepare message, send those prepare message to the other node. Other node will process PBFT prepare message. And after that, in this function, they will create commit messages. They will send commit messages. Once they receive commit message, they will process PBFT commit message. After they receive enough sufficient number of commit messages, they will create an execute message. Execute message is an internal message. They will pass it to the execution thread. Execution thread will execute and create client response and send that response back to the client. And once client receives that, it will increment the number of transaction in flights and send a new client request to the primary. And this loop goes on and on until it finished the simulation time. I'm not going to go over the commit, prepare, execution because they are same as pre-batch request and client request that I was explaining. So yes, I think that's it. If anybody has any question on this part.
Can you just repeat your whole summary that you just gave right now real quick? Yes. It was kind of fast, so.
Yes. See, the process is like this. The clients and the client thread start sending client requests. It will create client query batch messages, send it to the primary as we print out the process client batch in the primary as client query batch in the primary. After primary receive client query batch, it will create batch requests. Batch requests send it to everybody. As you can see in the workflow of PBFT, we send the batch request to everybody. Once everybody receive batch request, they will call process batch function on that message. Processing that message is just creating prepare message and send it to everybody else, as you can see in the flow of protocol. And after that, everybody will be receiving prepare message. Once they receive enough sufficient number of prepare message, they will start sending commit message. Once everybody receive commit message, they will call process PBFT commit function. In that function, they will start counting the number of commit messages they are receiving. Once they receive sufficient number of commit messages, they will execute the transaction and create client response and send the client response back to the client. And this process will happen again and again until the simulation is done.
Well, it's not simulation, the actual thing is happening until the experiment is done.
This is it's called simulation, the actual. But again, the one that I'm showing you is on the one machine. One 8-core machine is running 10 nodes. Each of those 10 nodes has 10 threads. So the number that you are looking at in the throughput are not the actual numbers, because we are running all of these machines on the same machine. Once you dedicate one, for example, 32-core or 16-core machine to every of these nodes, the numbers would be the actual numbers that the ResilientDB can scale up to that numbers. So, any other questions?
Can you go back to the terminal? I think for some reason, some of the threads on some of the nodes, so on the thread in the middle, right? Is there any reason why that shows as 0?
So which one? These are not
the
threads.
batch
These
requests.
Are nodes. So no. Oh, the thread 0. Okay. I didn't explain this part. I'm glad you asked here. So here is the pipeline of ResilientDB. As you can see, these batch creation threads are thread number 1 and 2 in the default setting. So the batch creations are in the primary. number 1 and 2 who are processing client query batch and creating batch requests. But in the non-primary replicas, the worker thread 0 is processing batch requests. So when you are seeing thread 0, it means that thread number 0 is processing batch requests. So in the non-primary node, the one who is processing actual batch requests are thread number 0 in all nodes. Why am I not reaching that? Here. The thread number 0 is processing. So this is the formation of pipeline. In non-primary nodes, the thread number 0 is processing process batch. And in the primary, thread number 1 and 2 are processing client query batch.
So kind of go back, Sajjad, if you can please go back to the previous, to the slide.
Mm-hmm.
So the runtime architecture that we have is a multi-threaded and it's pipeline. It's pipeline in the sense that operation happens in order, and it's multi-threaded is that it's not at a single thread, it's just doing all the tasks. So you can configure. So there's a couple of threads that just looks at the input, getting the messages. We have a couple of threads that package the messages and send it off where it needs to be sent. Now within it, there's again a whole bunch of other threads that are being used. There are threads that create these batch of transaction. There are threads that deals with doing the different phases of PBFT. Those are the worker thread, the sequencing, and so forth. There are threads that in the background, they do the recovery and checkpoints to ensure the recovery can be done faster. And there again, a set of dedicated thread that once the consensus is done, they actually go ahead and execute. So, and the execute is another set of threads that we have. So it's a highly parallel runtime environment. It's a highly multi-threaded. So in some of our setting, we allocate 16 or 32 physical thread to each node, so we can do these in a sort of the highly efficient and highly parallel way of handling these requests. So that's kind of another connection point to what each thread means. And we do have a lot of, so we look at the throughput, we look at the number of messages being processed, we look at the idle time, we look at every thread. We really do, when we do an analysis, we say why this consensus is doing better than the other, we come back to these runtimes. So we figure out where is the bottleneck, where in what part of the pipeline is it that we are bottlenecking the worker, we bottlenecking execute, and so we identify those, and then we adjust those number of threads in order to ensure that we get to our almost the steady state, so we up into our almost optimal state of execution. And it does give you, the ResilientDB does give you that flexibility to really allow you to configure and adjust all of these parameters, these runtime parameters. I guess they're more advanced. I mean, those are the more advanced type of topics.
Thank you for the question.
Yeah, that was an excellent question. So perhaps I think maybe going to the GitHub at some point, forking it, and everybody try to just try it themselves as well. So do you have anything else before you go into that stage?
No, Professor, I'm done.
Okay, yeah, so maybe I think this is kind of now make it even a little bit more hands-on. We all do this together. And so, and we see, hopefully there are not too many issues, especially since so many people are gonna be doing it at the same time. I mean, we've done it enough times, hopefully it's fairly reliable and stable, but it would be good that we all kind of try it right now, and if you face anything, it's an excellent time to just quickly be able to address it.
So wait, does this end up simulating like Byzantine nodes, or?
Yeah, so we do have also the ability to have the behavior of Byzantine nodes. And the Byzantine node, well, for example, what they could do, they just don't send any messages, or they send the wrong messages, or they ignore, and they only maybe send messages to only subset of Replica, or they don't respond to the client. So all of those comes to the experimentation. And so we do study those behaviors, and yeah, so that's important, yeah. So I think maybe, Sajjad, if you want to also maybe share your screen to walk through the process of forking the repo and getting it, and maybe all those steps, that would be nice too, I think.
I think it's straightforward. The forking is just
So
easy.
first, I guess, well, I mean, tell people everyone how to get here. So
Okay, the first thing is ResilientDB.com. If you can go to the ResilientDB.com, we have everything here. We have the publications that we have done on the ResilientDB here. We have a lot of publication on it, and actually good conferences. We have the timeline that what we have reached throughout the time and what we are planning to reach in the timeline. If you can contribute to any part of this, we would be more than happy to have you on the board. But yeah, the code is on GitHub. There's link all over the website to the GitHub. You can go to the GitHub, and I think the last version has been updated on September 3rd. You can fork this or clone it or whatever you want. And I have explained what you need to do, but there are also
well, again, let's
explanations here.
so Sajjad, let's so kind of do this step by step. So let's start with forking. So so everybody do a fork, and then you walk through. Once you have it forked, then what's the next step? How do you run it? Let's kind of do that very slowly together, I think. And today's recording I will post this recording after. Yes, thank you for that question.
Okay, so once you fork this, you will have it on your under your own account, and after that you just need to do the clone through the SSH. Can you see my screen? Yeah, definitely you can see. You do the Git clone. It will be your account name. Mine is Sajjad Rahnama. You would, for yours definitely would be your name. Once you clone it, you have everything here. You can create your own branch in your own fork, and once you want to contribute, you just create a pull request from your fork to the ResilientDB one. We will, okay, for example.
So before moving on, so Sajjad, let's make sure we're all on the same step. So can you share the link on the chat?
Yeah, sure.
And let's kind of see the step you've done as everybody else has done. Do they need questions? So we can do this step by step, all of us together.
So the link would be with your name. Once you fork it, the ResilientDB would be GitHub ResilientDB. Once you fork it, this would be.
Okay, so again, so let's do the fork steps again, step by step. Let's do the fork step that allows some time for everybody to do the fork, and then we go to the next step.
Okay.
So I guess first, everyone can go to the ResilientDB GitHub page, do the fork. Let's give a minute to everybody to do that, and then what's the next step? So let's do that step by step.
Then it would be something like this. That account in bracket would be your GitHub account ID.
Okay, so I guess the fork step, everything probably is done, those who want to do it right now. And so what's next?
So you just clone the code with this command, git clone. I have put it in the chat. Can you see the chat screen I'm showing you?
Yes, we can.
Yeah, here. Okay. After doing the clone, you will have the directory here, as you can see. And for example, I want to do a change. System worker thread pbfd. want to do these print statements. You have changed something. After you change something, you can commit those things and create a pull request that we can add to the actual repository that we have. And the process of that would be after you clone it, you change something, you need to do git add command, for example, for the thing that you have changed. Right now, I changed worker thread PBFT, I changed those print statement. You do not, that's just a simple example, not the actual thing. I'm saying once you change something and you want to publish the actual ResilientDB, the process is like this. You change something, you add those things, and after that it will be green git commit -m print statement. And after that you push those changes. I'm not going to push right now. You pushed your own master, and after that you will be going to your repository and create a pull request from here. Right now I don't have anything. You will do your changes, you will create pull request from here, and when you do the pull request to the ResilientDB, the actual ResilientDB, we will merge that to the master branch.
So I have a question. I tried to make the project and it's saying that there's a dependency of XED255.
Your first run was with Docker or not? Because when I was explaining, my first run was through the Docker. So when I went through the Docker untarred all these files here. And as you can see, there are a couple of tar and zip files here.
Oh, okay, I see.
The Docker script did that for me. If you didn't do it, just untar this file to these folders. If you do these, the dependencies would not have a problem. Just unpack these things. Any other questions?
So perhaps, I guess, maybe the next step, also running it once more.
The running was the same process.
Yeah, so now, yes, but for folks who are doing it right now, so we can take them step by step. What's the next command they need to run? So we do one more run, and then we can, I think, bring it to closure.
Okay. Should I run with the ResilientDB Docker command or here?
Maybe do it with the Docker command, but let's kind of make it step by step, make it as simple.
This is the vanilla project that I have cloned.
Okay.
Just change the worker thread PBFT and uncomment those two lines. And if you run this command, do it again.
Again, now we're running it on Docker, so there's 6 replicas on 4 clients on the code that was just checked out, and from Git, and So while this compilation is happening, again, if anybody has any question of the steps, so once you have it up and running, then I think you can now start experimenting and tracing it and getting into all the details. So compilation is completed now, starting up the nodes and so forth.
I have a question might sound silly. So we need to get Docker first, right?
Yeah. If you
does Docker have something like a GUI, like Wings app?
Yes, I think, but you don't need to. The only things you need from Docker
I'm not that familiar or comfortable with using terminal, so yeah, maybe a GUI is better.
Yeah, there are a couple of GUIs for Docker, but yeah, for this purpose, you do not need to do anything with Docker. You just need to Docker be up and running. Did I answer your question?
Oh yeah, thank you.
So how long is the run, Sajjad, right now? Is it 2
1
minutes?
minute of warm-up, 2 minutes of run.
2 minutes, okay.
As you can see, I came here in the first node and just tailed the first node results. This is what's happening in the first node. Even if you are running with this Docker command, all those results would go to the results folder that I have gone there and just tailed the number 0. Because we have printed out the client query badge, you can see the printing for client query badge. And right now, we have, I think, 40 more seconds.
Wait, so what exactly is Docker and how does that help in this scenario?
Okay, thank you for your question. The point is that in order to have a distributed code running, you need different nodes. You need a specific IP address for each node. Okay, you cannot run all of them with localhost if you are doing your own. You need to have different machines. The Docker will give you different machines with different IP address on the same machine. So now in the Docker, you have different IP addresses that you can look at them as a completely separate machines, and you can initiate a socket with them and send a message to them.
Okay.
So the code is distributed. You need to have, for example, at least 4 machines to run PBFT and 1 client, at least 5 machines. In order to have 5, you cannot have 5 different IP addresses on your system. You cannot run all of them with same IP addresses 127.0.0.1 because it would interfere. For example, how can you send a message to node number 3 if all of them have the same IP address? You can do with these different ports, but that's not something implemented in ResilientDB because that's not useful at all to have it on one machine. And the Docker implementation is just, the purpose is to give you a little bit of area to develop something on one machine. Once you develop on Docker, once you go to the actual system, usually some bugs comes up because when everything is faster and pipelined, race condition and all those stuff happen, and then you also need to debug on the actual environment. But the Docker is just for development purpose, not the run purpose. Did I answer your question?
Yes.
Sure.
There's
And
also one comment on the chat, Sajjad, if you can look at it.
Sure. I suggested you to what? I think your problem is something with your G++ compiler. We can take a look at it offline. But the question, are you compiling it in your machine or from inside the Docker? You need to compile it from the inside the Docker. If you remember, I didn't compile it here. I did the Docker exec, this one, and here make clean, make -j2, for example. You should not see, here is inside the Docker. As you can see, this is inside the Docker. I should not compile it from the outside.
I have a question. Just want to make sure that after I fork the code from GitHub, and if I want to change something and push it to GitHub, it won't change the original code you guys have, right?
Yes, it won't. Yes.
Okay, great. Good to hear that I won't mess things up.
No, you cannot. You do not have access.
Yeah. Thank you.
Yeah, sure.
Yeah, so anytime that you kind of do it, because you fork this now, you have your own copy, you can now experiment with it, and whenever you're ready, you can always actually send your code, push it to the main repository, but there is some sort of checks and balances that happens there. You make the request, things will be reviewed, and so we have a whole pipeline for once you get to that stage to push the code into the main public repository.
Yeah, I was worried about I would mess things up in the master branch, so I don't want to do that.
Thanks. Any other questions?
All right, that was an excellent tutorial. Great job, Sajjad. Thank you so much. And we will have, this has been recorded, and we will have it on the website as well too.